Hello everyone. Before starting the lesson, try the warm-up. Complete the table of values for y equals sine x. So here are different values of x. Here you can fill in the values for y for each value of x. Use the equation. Then answer the follow-up questions. Is it a function? Is it periodic? And without using your calculator, see if you can predict the value of sine of 390 degrees. So pause the video and try to answer each of these questions. You can use your calculator to find these values. Is it a function? Well, remember what a function is. Each input has only one output. Or each value of x has only one value of y. Is that what we see? Yes. That's exactly what we see. Each value of x has only one value of y. There weren't two possible answers in each of these boxes, only one each. So that's a function. Is it periodic? This relates back to our last lesson where we looked at what periodic functions are. A periodic function is a function that has a pattern that repeats at regular intervals. Is that what we see? Looks like it. Goes from 0 up, then back down, then down, and back up. So we start at 0, we end at 0, we've gone up and then down and then back up to 0 again. Looks like it's periodic. Now that we see this pattern, this periodic pattern, we can not have to use our calculator to predict the value of sine of 390 degrees. That's just 30 degrees more. So if we follow the same pattern, we can see it's going to be 0.5. So in the warm-up, we looked at y equals sine x. This is the most basic sinusoidal function, or functions based on the sine function. We're going to identify the characteristics of sinusoidal functions, and we're going to determine whether a periodic function is also sinusoidal. That's the goal of this lesson. So first we're going to go back to this function, sine x, that we looked at in the warm-up. Notice I'm using function notation again. Instead of y equals sine x, I'm writing it in function notation f of x equals sine x. The function named f as a function of x. X is the input. The value of the function will be the output. And using that function, I came up with this table of values. For different values of x, I have the corresponding value of y. Here on the screen, you can see a grid that we can plot these points on, and it looks like this. But if we want to sketch this function for 2 complete cycles, what would that look like? Well, here's one complete cycle of this function. It goes up, down, back up to where we started. I could take this one complete cycle, and it's like I copy and paste it back over here, and I'll end up with 2 complete cycles. So it ends up looking like this. This cycle looks exactly the same as this cycle because it's the same pattern that repeats over and over again. So this wavy pattern is what every sinusoidal function will look like. Any equation that has sine of something in it will look like this pattern. And this is the basis for all sinusoidal functions. Now here's that same function, just graphed a little bit neater than what I showed you. The same 2 cycles for f of x equals sine x. We're going to look at what the equation of the axis is, the amplitude, the period, also the domain and range. Equation of the axis, the amplitude, and the period, these were covered in the previous lesson. So if you forget what those are, you might need to review your notes, or your help sheet has definitions of these as well. Domain and range we've been talking about throughout the whole course so far. So I'd like you to pause the video and see if you can fill in the blanks here. The equation of the axis is the equation of this line that goes right through the middle of our function. right through the middle, so it's an equal distance from the highest and lowest values. For this function, that line is on the x-axis, which has an equation y equals 0. The amplitude is the distance between the axis and the maximum or minimum value. So if I look at my axis and I look at the maximum value, we're 1 unit away on that scale. So the amplitude of this function is 1. The period is the length of one cycle. So if I go through one complete cycle on this graph, I'm going through 360 units on the x-axis here. Now, some people have trouble figuring out the period because they don't know where to start and how long one cycle is or where that would be on the graph. So, some ideas. You can start here at the origin, follow the curve until you get back to where you started. Not here though, because the pattern doesn't start over again here. From here we're going down, from here we're going up. So you go up, down, still down, back up. That pattern's going to go up again. So from here, the pattern would start to continue or repeat from where it did here. So this right here is one complete cycle from 0 to 360. So the period is 360. Or you can look at from one peak to the next peak, from negative 270 to positive 90. That's a span of 360. Or from the lowest point to the next lowest point. That's also from negative 90 to 270. That's 360. So anywhere you look, to go from where you start to where that same pattern starts to repeat again, it's 360 degrees. So that's the period for this function. Domain and range are the possible values of x and the possible values of y. For this function, there are no restrictions on the value of x. This pattern will continue forever in either direction, left and right. X can be any number, negative, 0, or positive. No restrictions. The range, however, does have restrictions. All the values of y are between negative 1 and positive 1. That's the lowest and the highest values. So, just as a reminder, this is how we write the range. Y is an element of all the real numbers with this restriction. Y must be greater than negative 1 or less than 1 or equal to negative 1 and equal to 1. Now you have a chart similar to this on your help sheet for the unit. So you should pause the video at this point and complete that section. A function is called a sinusoidal function if it has the curved form of a sine wave. That wave that we just looked at, where it goes up, down, up, down, up, down, the maximum and the minimum values never change, and the period is always constant. All sinusoidal functions can have f of x equals sine x as their parent function. So if you're looking at the graph, it'll have that wave form. And if you're looking at the equation, it will have sine in the equation. And that's how you'll know you're dealing with a sinusoidal function. So here are 3 different graphs, and I have 2 questions for each graph. Is it periodic? And is it sinusoidal? So pause the video and see if you can answer both of those questions for each graph. And if you get stuck, you can just wait till I take it up. Let's start with the question, is it periodic? This function is periodic because the exact same pattern keeps repeating. This function is also periodic because we can see from here to here is one complete cycle and the exact same cycle repeats over and over again. This function is not periodic because although we have this wavy pattern, it's not the exact same cycle every time. We can see the amplitude keeps increasing. So this is not periodic. Now let's look at whether they are sinusoidal. This one is because we have that wave pattern. This one is not because we don't have that smooth wave pattern like we see here. So although this function is periodic, it is not sinusoidal. This function, because it's not periodic, it cannot be sinusoidal. Even though you see a wave, it's not a constant wave with an unchanging amplitude. So this cannot be sinusoidal. Sarah is sitting in an inner tube in a wave pool. Her height against time is graphed here. Height above the pool bottom, I should say. So we can see she starts 2 meters above the pool's bottom. Her height goes up, then it goes down, then it goes up, then it goes down. This makes sense because she's riding the wave. Pause the video and find these values, the equation of the axis, the amplitude, and the period. The equation of the axis is this dotted line I've drawn here, y equals 2. The amplitude, well, from the central axis to here, I'm going down 0.4 units, meters I should say, 0.4 meters. And the period, I've highlighted one complete cycle, takes 3 seconds from start to finish of the cycle. I could have looked from here to here as well, and I would notice that it's also a span of 3 seconds. Now a follow-up to this would be, what do the axis, amplitude, and period mean in the context? So we figured out what these are for the graph, but this is talking about her height above the pool bottom over time. So what do these values actually mean when we put it into the context of describing what's happening? Well, the axis of the function, y equals 2, means that if the waves just stopped, this is where she would be sitting at 2 meters above the pool's floor. So the pool is 2 meters deep. The amplitude is 0.4 meters. So if we think about what that means, the waves fluctuate from 0.4 meters below that line to 0.4 meters above that line. So there's a distance of 0.8 meters, a change of 0.8 meters in height between the top and bottom of the wave. So these are pretty large waves. That's what we can get from that. The period is 3 seconds, so that just means there's a new wave every 3 seconds. So this is just an example of how you can relate these values you're getting about the graph to explaining what's happening in the context of what's being described. And now it's time to practice. So you've got some definitions of periodic behavior. You know what a sinusoidal function is, and you should have on your help sheet filled in table of values, graph, the equation of the axis, amplitude, period, domain, and range of your parent function, f of x equals sine x. Using that, you should be able to describe a situation that's being graphed as a sinusoidal function. So practice these questions, and if you run into any issues, please reach out for help.